Here we are going to see what happens when a parallel ray is incident on a concave mirror. Especially the ray passes through a focus point of the mirror. How does it happen mathematically? We are going to see that. So here is a parallel line, and after reflecting from the mirror, it passes through the focus point. So we know from geometry that a radius, since this mirror is part of an sphere, and from geometry we know that any radius should make 90 degree with a tangent line at the circle. So this angle is 90 degree, and from law of reflection we know that that angle of incidence is equal to the angle of reflection. So these theta should be equal, and these two are parallel lines, and this is an oblique line. So this angle should also be theta, and if these two angles are theta, then this angle should be 180 degree minus 2 theta, since the sum of interior angles in any triangle is 180 degree. So we will subtract 180 degree 2 theta from 180 degree. So this angle is 180 degree minus 2 theta, and if this distance, this length is radius, the radius of the sphere it is, this mirror is part of this sphere, and if you assume this distance from where the ray passes through, we are going to assume it as x, then this distance should be r minus x. So what is the value of x? And we are going to prove that this should be half of the radius. How does it happen, and is it true that a parallel ray should pass through half of the radius distance from the mirror? So let's see it mathematically. How does it happen? So now we are going to apply the sine rule in any triangle. Basically it says that a by sine a, this length is we are naming it as a, capital A, and in front of that angle is a small a, and here in the same way the side length is b and angle is the small b. So the sine rule says a by sine a is equal to b by sine b is equal to c by sine c. So these ratios should be equal, that is the sine rule, and we are going to apply this sine rule in this scenario. So here it will happen that r minus x by sine theta is equal to r by sine pi minus 2 theta. We can see that this distance is r minus x, and theta is here. So in front of that angle this side length is, and in here it is r. So in front of this length this angle is which is 180 degree minus 2 theta. So we are going to put applying sine rule. So this will be sine 180 minus 2 theta, and now if we solve sine 180 degree minus 2 theta is equal to, we know that sine 2 theta. So this will be simplified as this, and then we are going to further simplify it. We know from trigonometric formula that sine 2 theta is equal to 2 sine theta cos theta, and now we have come to this line, and now we are going to make an approximation or assumption that this theta is this angle of incidence is very small, it is almost 0. So if you assume that this theta is 0 or approximately equal to 0, then cos 0 will be 1, and by that sec theta is equal to 1 or sec 0 is equal to 1. And if you are going to put into that, then we will get sec theta as 1, and x will be equal to r minus r by 2, and here will this distance in which we are originally interested in, this distance will be the half of the radius, and in that way we have proved here that focus distance is half of the radius length. So that is our proof here, that focus length is half of the radius length. Thank you.